Hi guys, I'm Keshav Shastri. Welcome to the Cracku family. I hope you have started a full-fledged preparation towards CAT. You're preparing every day. So what are we going to do today? Today we are going to look at 3 questions from last year's Slot-2, which are in the range of moderate to difficult or slightly difficult. What is the approach? How should we go about those questions? So that we get a feel of how was CAT last year. Overall, the Slot-2 DILR was slightly difficult as compared to Slot-1. We had Venn diagram question which had 2 easy questions and 2 were fairly tricky. So you can call it moderate to difficult, and there was a profitability question on 3 companies. This is like a replacement for bar graph or pie chart question. They were not very difficult, but multiple factors were involved. If you get one thing wrong, then the overall set would go wrong. This is slightly you can categorize as difficult. This is again, these 2 questions are like if you get the logic right, if you get one aspect of logic right, then you can do the entire set. You had a coding question which many students struggled, and CAT loves to ask math based puzzles, solving puzzles, so we'll do this one today as well. We had a linear arrangement question, interview question. This was very easy. In fact, this was easier than the sales question, and we had accreditation of 8 institutes. This is fairly doable, but too long. Like there are multiple factors involved, multiple parameters. If you look at a question like this, it is better to drop it because it is very time consuming. The last question was economy gold class tickets. This is again 2 questions were easy, 2 questions were fairly tricky. So you can classify it as easy to moderate. So let's look at the questions now. Let's look at this question. So this is a coding and decoding based question. This is a sort of a puzzle based question where you deduce things. Every year there is a question like this, a math based puzzles. CAT authors love to give questions like this, and many students found it very difficult to solve. It is not a very difficult question, but you need to get the right order when you solve this question, because if you start out on the wrong foot in this question, it will get a whole lot difficult after that. So you just need to solve it optimally, going in the right order. Let's try to solve it. According to a coding scheme, the sentence Peacock is designated as the national bird of India is coded as this big number. So first of all, you need not write down this entire thing. Many students write down Peacock is designated as national bird of India and then the sequence. That itself will take you about 1 minute. As and when you are solving, you can write down what is required and try to deduce. Or if you feel this is optimal for you, you can do it that way also. So let's look at the conditions. The coding scheme has the following rules. The scheme is case sensitive, does not distinguish between upper and lower case letters. Each letter has a unique code, which is a single digit from among 1 to 9. Okay, the digit 9 codes 2 letters and every other digit codes 3 letters. Okay, so they have given this as well. We know that there are 26 alphabets. Each of the digits 1 to 9 code for 1, 2 or multiple characters, but here they have specified that digit 9 codes for 2 characters while all the other digit codes for 3 characters. So 8 into 3 plus 2, so that will be 26. So all the 26 characters are coded by 1 to 9, where 9 codes 2 characters while all others codes 3 characters. Then the last condition says the code for a word is constructed by arranging the digits corresponding to its letters in a non-decreasing sequence. So that is, it is arranged in an increasing sequence. Let's say this is what is coded as 3 5. Let's say if considering that is coded as 5 3, then when it is coded, it will be written as 3 5 because it is arranged in an increasing order. The same will happen with all the words. So we have to figure out which letter corresponds to which number. Let's try to solve it. One, 2, 3, 4, 5. It is given in the question that 9 is coded for 2 characters while all others are coded for 3 characters. Okay, so how do we approach the question now? First of all, we need to look for small words, as small as possible, and they need to have some sort of repetition of a few letters. The small words we have is small, as is small, and of is small. Among these, we can see that is and as, both of them have s in common. So let's write down is and as. Is coded as 3 5 while as is coded as 5 6. So among both of this, we can observe that only 5 is common. S is common in the word and 5 is common in the code. So S has got to be 5. So we'll write down 5 as yes. And then we have I stands for 3. We have I here, and then we have A is for 6. So we have A here. Until here we have got. Now we have 3 characters, one S, I and A. Using this, which other word can we target? So shall we target peacock? There is nothing in that. Shall we target designated? There is I, S and A, but it's very big word. It's better to stay away until the last. And then we have there is nothing in common. There is national, again a little big word. We have bird, there is 1 letter in common. And lastly we have India. India has 3 of them. I twice it comes and A comes once. So the best one would be to target India. Let's write down India. India is coded as 13366. So right now we know that I stands for 3. So we have 2 I's here. Those 2 3's you can cancel. We have A stands for 6. So A and 6 we can cancel. Now we have confusion between N and D. So this implies that N or D, either of them is 1 or 6. N or D is either 1 or 6. So where can we find N or D? Which is the next one? Until now, which are the words that we have done with? Now we are done with is, we are done with as, and now we are done with India. Only confusion we have is N or D is one of them is 1 or 6. So you can either target national, which has N, or you can target bird. Since bird is smaller, let's first take bird. Okay, I'll write down bird. Bird is coded as 1334. Bird is coded as 1334. What do we know? We know that I is 3. So we cancel out 3. Then we have BRD. Here D is either 1 or 6. There is no 6 present. There is only 1. So this 1 got to be D. You can write down D is 6. D is 1. We get D is 1 and N is 6. N is 6. D is 1 here. So this arises one more confusion here. There is one more choice. That is B or R is either 3 or 4. We have 2 cases. B or R is either 3 or 4. Then let's go ahead. Let's target national. We know that N is 1. We already got that. N is 6. We got that. Let's say we'll write down national. National is coded as 13666689. So what do we know among this? We know I is 3, A is 6 and N is 6. So NA, all of them are 6. All these 4 go away. I is 3, 3 goes away. Then we have TOL and we have 189. So TOL and we have 189. We do not know either of the 3. So where can we find T or O or L? If we look in the sentence, then we have the is there, off is there. Off is a smaller one. So it is better we target off. Let's say we target off. I take OF. OF stands for 79. So what is common in these two? Only 9 is common. So naturally O has got to be 9. O is 9 and F is 7. You get 2 from this. I'll write down O is 9 and F is 7. After that, still there is a confusion between T and L. T or L is either 1 or 8. T or L is either 1 or 8. So let's take the is coded as, we can say it as 458. The is coded as 458. Only 8 is common among these two. So 8 is T here now. Get 8. This will arise another confusion that H or E is 4 or 5. So from this we have 8 is T and L is 1. So we'll get 8 is T and L is 1. Well, we know that H or E is 4 or 5. So where can we find either H or E? We can find E in Peacock. We can find E in designated as well. All the others are done. Only Peacock and designated is left. Peacock is smaller. So it is better we target Peacock first. So I'll write down Peacock. Peacock is coded as 5688999. 5688999. So I have a confusion between H or E, and there is only E present. E is either 4 or 5. There is only 5 present once here. So this E has got to be 5. So E is 5 and H is 4. I'll write that down. E is 5 and H is 4. And I know A is 6. So there is one A here. I'll target that. Apart from that, what do I know? I know that O is 9. I'll scratch off 9. So now we are left with P, CC and K. So this CC can either be 8, 8 or CC can be 9, 9. Now you have to remember one important factor that they are given before. That 9 codes for only 2 letters. It does not code for 3 letters. So let's take the case where CC stands for 8, 8. Then PK will be 9, 9. We already know that 9 codes for O. So if both PK codes for O, then 9 will have three characters coding. So it is not possible. So C has to be 9. So we have C is 9 and PK is 8. These two is 8, C is 9. This is the only possible case. We will write C here and we will write PK here. And lastly, we have the word designated. Let's write down designated. DESIGNATED. This is coded as 113555678. So we have most of the stuff. D is 1, we know that. There are 2 D's, we will cancel these 2. E, we found it as 5. E is 5, S is 5, A and N is 6. So E is 5, S is 5, A, N, both of them are 6. I, it is 3. And then T, what is T? T is 8. And we have E, E is again 5. So we are only left with G and we are left with 7. So G has got to be 7. This is the last one. So I get G as 7. So we have reached the conclusion. We have used all the characters and finally we are left with this one conundrum, that B or R is 3 or 4. Among all the given letters, we have got everything except for B or R. B or R is either 3 or 4. Okay. So let's look at the questions now. First one is, what best can be concluded about the code for the letter L? So we have already found L. L is number 1. So it is 1. They have given the options. The answer is option A. Second one, what best can be concluded about the code for the letter B? Do we know where is letter B? No, we don't know. We have a confusion between it is either 3 or it is 4. So what are the options? We have an option 3 or 4. So this is the right option. Third one, for how many digits can the complete list of letters associated with that digit can be determined? Okay. How many digits? Let's say many students fall into this bait and they will only mark as 1. That is because 8 codes for everything. But remember that 9 codes for only 2 characters. And 9 has also coded for everything that it can code. The maximum it can code. So there are 2 such digits. What have they asked for? For how many digits can the complete list of characters or letters associated with it can be identified? That is 2. One is 8, which has 3 characters, and one is 9, which has 2 characters. So the right answer is 2. Last one, which set of letters cannot be coded with the same digit? SEZ, is SEZ possible? Yes. For 5 we can do SE is there, we can take SEZ, it is possible. IBM, is IBM possible? Has BM come anywhere? No, we have not used B or M anywhere. B, there is a confusion. B can come to either 3 or 4. So certainly B can come here. M can also come. So IBM can be coded for the single one, that is number 3. SUV, is this possible? SE is already coded for 5. So SUV can never come because SC is already coded. So naturally the answer is SUV. Let's also check XYZ. Is XYZ possible? XYZ is not used anywhere. This is not X. This is to represent that 9 can only take 2 characters. XYZ is not coded and 2 is entirely empty. So this can be XYZ. So XYZ is certainly possible again. So the right answer is SUV. Let's look at the first question. Fun Sports provides training in 3 sports: Gilli Danda, Coco and Ludo. So this is naturally a Venn diagram question as soon as you spot it. Currently it has an enrollment of 39 students. So overall we have 39, each of whom is enrolled to at least one of the sports. So there is no one who has not enrolled to any sport. So we have Gilli Danda here, we have Coco and we have Ludo here. The number of students enrolled only in L is double the number of students enrolled in all the 3 sports. So let's first give terminologies to each one. A, let's say this is B, this is C, this is D, this is E, this is F and this is G. See, the objective of a Venn diagram question should be to minimize the number of variables. As and when you proceed, try to minimize the variables, because if there are too many things, you have to wrap around your head about too many things. It's too difficult to solve it. So how do we do it? Let's try to do it that way. The number of students enrolled only in L is double the number of students enrolled in all the 3 sports. So we know that only L is G, all 3 sports is E. So G is double of E. So let's replace G with 2E. Then what do we have? There are a total of 17 students enrolled in G. So if there is a specific input given, then it is very useful. Let's say this is 17. The number of students enrolled only in G is 1 less than the number of students enrolled only in L. So total we have that only G is 1 less than only L. So we have only G plus 1 is only L is 2E. So again, can we replace A? Yes, we can write A in terms of E. So we'll write A is equal to 2e minus 1. So again we'll eliminate the variable a, we'll write it as 2e minus 1. What do we have after that? The number of students enrolled only in K is equal to the number of students who are enrolled both in K and L. So both K and L is E plus F, this region. So both K and L is E plus F. That is equal to number of students who are enrolled only in K. So we have C we can replace by E plus F. Then the next point is the maximum number of student enrollment is in L. So whenever they give maximum or minimum, you'll be using it in problems. You cannot forget that. So you have to keep it in back of your mind. It's very critical. The next one is 10 students enrolled in G are also enrolled in at least one more sport. So what are they trying to give the information here? We already know that Gilli Danda there are 17 students playing and there are 10 students who have enrolled to one more sport. So there are 10 students who have enrolled to either 2 sport or 3 sport. So 17 minus 10, naturally there are 7 students who have enrolled to only one sport. So we'll get the information that 2e minus 1 is equal to 7. So from this what we can do, 2e is equal to 8. So we get e is equal to 4. So we'll substitute wherever possible, 2e minus 1, this will write it as 7, 2e will write it as 8, all 3 sports is 4. This will be 4 plus f. Then what else do we have? We also have the information that overall there are 39 students who have enrolled. So and 17 students have enrolled for Gilli Danda. So we can summate these things to get the value of f. Let's say 4 plus f plus 8. This value should be equal to 39 minus 17 because we are not including G. This will be equal to 39 minus 17. This will have 12 plus 2f is equal to 22. So we'll get 2f is equal to 10. So f is 5. So wherever f is there, we'll replace that. This will be 5. So overall we'll get it as 9. Again we'll replace this by 5. So only 2 parameters are left. Can we reduce the variables further? We know that the total is 39. So what can we do from this? This is 7, 4, 11, 11 plus 8, 19, 24, 33. So 6 is left. So let's say b plus d is equal to 6. b plus d is equal to 6. So if we take this as b, then d will be 6 minus b. So until here it is fine. Now we can look at questions. The first question is, what is the minimum number of students enrolled in both G and L but not in K? I have redrawn the entire set again so that it is easier to visualize. So the question says, what is the minimum number of students enrolled in both G and L but not in K? So both G and L is 6 minus b plus 4 but not in K. So they are asking for the minimum value of 6 minus b. So we cannot forget this point. The maximum student enrollment is in L. So using this condition, we have to minimize the value of 6 minus b. So what are the possible values for b? If you observe the diagram carefully, here we have 9, here we have 8. So you can get a feeling that this portion should be greater than this portion, so that L is always greater. But let's try to calculate. Let's say this is 9 plus b plus 4 plus 5. So that will be 18 plus b. We have 18 plus b here. Then we have 4 plus 5 plus 8. 8 plus 9, 17, 23 minus b. 23 minus b. So this is k. This is the total value of k. K is equal to 18 plus b. We have L is equal to 23 minus b. So let's say if b is 0, L is L greater. When b is 0, we have L is equal to 23, k is equal to 18. So L is greater. Let's say b is 1. This value is 1. We have 23 minus 1 is 22, k is 19, again works. Let's say b is 2, 23 minus 2 is 21, k is 20, again it works. Let's say b is 3. When b is 3, L is equal to 20 while k is 21. So it doesn't work. We need not even check this because this value is lesser than 8. So naturally every time if this one works, we need not even check if the equation holds for Gilli Danda. That is because number of students enrolled to only L is 8 and number of students enrolled only to G is 7. So when this is greater than this is naturally hold. We can check this. Let's say this is b is 2. Then this is 7 plus 4 is 11. The sum of these two is 6. This is 17. So we have 3 values for b. B can take the value 0, 1 or 2. And all these times G must satisfy. G will be lower than L. That is because if you look at this, only L, students enrolled to only L is 8 while students enrolled to only G is 7. It is naturally lower. If you take an example, let's say we take b value as 2. Then we have L is number of students enrolled to Ludo is 8, 9, 17. 17 plus 4 is 21. Here we have 21, while here we'll have 7 plus 4 is 11, 11 plus 6 17. So most of it will be, in all these three cases it will work out. So we have three possible values of B. What is the question asking us? What is the minimum number of students enrolled in G and L but not in K? So we have to minimize this. When is this minimum? When B is maximum. Maximum possible value of B is 2. So the minimum possible value is 4. So the right answer is 4 for this. Let's look at the next question. Let's look at the second question. If the number of students enrolled in K and L are in the ratio 19:22, what is the number of students enrolled in L? So as soon as you see this big number 1922, overall students itself is 39. So it will immediately tick you off that this is the number of students enrolled in K, this is the number of students enrolled in L. So naturally the answer will be 22 immediately. But let's look at it for confirmation's sake. They have told us that K is 19. So if K is 19, what do we have? 9 plus 9, 18. This is 1. So B value we have as 1. So this will be 5. 6 minus B will be 5. So we have 4 plus 5, 9. 9 plus 8, 17. 17 plus 5, 22. So number of students enrolled in L is 22. So the right answer is 22. Let's look at the third question. Due to academic pressure, students who are enrolled in all three sports were asked to withdraw from one of the three sports. Okay. So what does this imply? So there are 4 students here who have enrolled to all the 3 sports. They are asked to withdraw. So they can go either here or this way or this way. Let's read further. After the withdrawal, the number of students enrolled in G was 6 less than the number of students enrolled in L, while the number of students enrolled in K went down by 1. After the withdrawal, how many students were enrolled in both G and K? So what does the second statement say? It says that while the number of students enrolled in K went down by 1. So the number of students enrolled in K went down by 1. When can this happen? There are 3 ways that all these students can go. They can either go here, this way or this way. If these students come to this way or this way, then the value of K will always remain the same. If it has went down by 1, then exactly 1 student should have gravitated this way. So we can say there are 1 student has come this way and 3 students have gone this way. So we can reframe the entire diagram. So let's understand this. It says 1 student K, number of enrollment in K went down by 1. So 1 student should have gravitated here. So 6 minus V will become 7 minus B. There are 3 students who have went in either direction. So let's say this is X. If this is X, then this will be 3 minus X plus 3 minus X. And this will become 0. What other information have they given? They have also given the information that the number of students enrolled in G was 6 less than the number of students enrolled in L. So this is G and this is L. So 7 plus, we have 7 plus B plus X plus these two will be same. They'll either way they'll get cancelled. So this is 6 less. So let's add 6. This will be equal to 8 plus 8 minus 6. That is equal to 8 plus 8 minus X. That will be equal to 16 minus X. So we'll have 13 plus B plus X is equal to 16 minus X. So we'll have 13 plus B plus X is equal to 16 minus X. So we'll have 2X plus B is equal to 3. We got the condition that 2X plus B is equal to 3. So what are the possible values of X and B? Let's say X is 0. If X is 0, then B will be 3. If X is 1, 2 into 1 is 2, then B is 1. If X is 2, B will be negative 1, which is not possible. Let's say, can we take any other value for B? Let's say B is 2. If B is 2, then X is half. X must be a whole number. So again, this is not possible. These are the only 2 cases. Can we eliminate one of the cases? Previously we already saw that B can take only 3 values, that is 0, 1, 2. This is because of the condition that L must be the greatest. If B is 3, then L is not the greatest, K will become the greatest. So B can occupy only 3 values, that is 0, 1, 2. So in this case, this is the only possible, this cannot take, so we will eliminate this option. So B is 1 and X is 1. So we have this as B plus X is 2, this will be 7 minus B will be 6. Let's look at the question. The question says, after the withdrawal, how many students were enrolled in both G and K? So both G and K this is already 0, so both G and K will be 2. So the right answer is 2. Let's look at the last question in this set. Due to academic pressure, the same condition holds. Students who were enrolled in all 3 sports had to withdraw from one of the 3 sports. After the withdrawal, the number of students enrolled in G was 6 less than the number of students enrolled in L. So again, everything is same. While the number of students enrolled in K went down by 1. After the withdrawal, how many students were enrolled in both G and L? How many students are there in both G and L? We already saw this. We know value of B is 1. So 7 minus B is 1. 7 minus 1 is 6. So the right answer is 6. Right answer for this is 6.